Hello students, welcome to another video of metric space. Today we will discuss some definitions in the metric space. So first definition is open sphere. Definition of open sphere. So definition is, let XD be a metric space. XD be a metric space, and suppose this X belongs to X and R greater than 0, R greater than 0, then the set SR of X, the notation is capital X suffix R of X, SR of X. This set is called open sphere. The set is Y belongs to X such that distance of XY is less than R. It's called, this set is called open sphere about X. About X means the open sphere centered at X and with radius R, that is this with center X and radius R. So this is the theoretical definition. XD be a metric space, and this X belongs to X and R greater than 0, that is X is element of X and R is any non-zero number. Then this set of SR of X. SR of X is the notation of open sphere S suffix R of X, and this given by this set is equals to Y belongs to X such that distance of XY less than R. It's called open sphere. For example, suppose this is XD be a metric space, and suppose this X is any element of that set X, then for any R greater than 0, suppose this is radius, and if you take this radius and draw the sphere, then this sphere is called SR of X, that is open sphere. This sphere is called open sphere. The definition is, the elements of the SR of X are the elements of X. So the elements of SR of X, that is the elements of open sphere, are the elements of Y, because this is whole things are going in metric space XD. So this whole space is metric space XD, and so the elements in this whole set are these elements of X, and we are taking this subset of this space, that is this space SR of X is just the subset of this whole space. So the elements in this smaller, that is the elements in this smaller subset, are the elements of X. So Y belongs to X, that is the elements of set open sphere. The elements of the open sphere are the elements of X, that is, suppose this, if you take any element in this set, suppose this dotted sphere is SR of X, and if you take Y, this Y element of SR of X, but SR of X is subset of X, so Y must be the elements of Y must be the element of X, and Y belongs to X is the element of SR of X whenever the distance between X and Y is less than this R. This is R. R is the maximum distance. This distance is strictly less than. So the elements of the set SR of X, or the set SR of X, is the open sphere of this form. Whenever we take any elements of this sphere, that element must be in interior of this boundary. Suppose this is boundary of the open sphere SR of X, and if you take any elements of SR of X, the distance between that two elements, that is center and that element Y, must be strictly less than R. So this is Y, and the elements which are strictly less than this is distance R, and the elements which forms distance strictly less than R are the interior of this boundary. So I'm drawing this in dotted way. So this is Y. Suppose Y belongs to SR of X whenever distance between X and Y is less than R. So this distance is less than R. Clearly these all elements are the elements of SR of X. That is, if we exclude this boundary, then the remaining interior elements are the elements of SR of X. Open sphere is, this is the theoretical definition of open sphere, and in diagrammatically we can say that this dotted sphere is open sphere whenever, if you take any element of that sphere, then the distance between that element and center must be less than R. So we call this dotted sphere as open sphere if we exclude this boundary. then this is open sphere. This is the definition of open sphere. And one note is, any open sphere, if we take any open sphere, then that open sphere is non-empty, because this, at least that open sphere contains its center. An open sphere is always non-empty. Since it at least contains its center. Now the next definition is closed sphere. Closed sphere. The notation, similar definition is, let X be a metric space X belongs to X and R greater than 0. Then the notation of the closed sphere is S R of X. This is closed set, S R of X, and this set is given by Y belongs to X such that distance of X and Y is less than or equals to R. Closed sphere, notation of the closed sphere is S R of X close bracket, which is equals to Y belongs to X such that distance of X, Y is less than or equals to R. So if we know the open sphere means the sphere which does not contain its boundary, and if that sphere contains its boundary, then we call that sphere as closed sphere. This is the definition of the set is called closed sphere. Set is called closed sphere. So suppose this XD be any metric space, then a closed sphere must contain its boundary. So suppose this is X, this is R. So this is S R of X. This is the definition of closed sphere. Now we will take one example. Suppose the real line, consider the real line R with usual metric. Usual metric means standard metric or absolute value metric, with usual metric, and we will show this S R of X, that is open sphere on the real line. Open sphere on the real line is, we will show this S R of X is equals to the interval X minus R, X plus R. This question is maybe asked for 2 marks. That is, show that on a real line open sphere is open interval X minus R, X plus R. So here we have given this RD be a metric space, RD be a metric space with usual metric. Usual metric, standard metric and absolute value metric are the same matrices, same matrix, and the definition of usual metric is distance of xy is equals to mod x minus y. Therefore, for all xy belongs to R, distance of xy is equals to, definition of usual metric is mod x minus y. Now we have to show S R of X is equals to X minus R, X plus R. So definition of S R of X is Y belongs to X such that distance of xy less than R. Now consider that definition. Consider S R of X, this is open sphere, is equals to, definition, theoretical definition of open sphere is S R of X is equals to Y belongs to X such that distance of xy less than R. Distance of xy is strictly less than R. This y belongs to x as it is, but distance of xy is equals to mod x minus y. So using that here we can write this, and in the modulus we know that a minus b is equals to b minus c. If we interchange these numbers and this modulus, then there will be no change. Now this y belongs to x such that mod y minus x less than R, mod a is less than c. This is the formula that we have seen in the T.Y.B.Sc level. So here instead of writing x, here we have given that RD, metric RD. Instead of XD we have given that RD, so we can write directly R. can write R. Now using the property of that modulus, we can write this y belongs to R such that this minus R is less than mod y minus x, y minus x is less than R. Y belongs to R such that minus R less than y minus x less than R. Now adding x on both sides, on all these three sides, we will get y belongs to R such that this x, adding x, so we get x minus R is less than x minus x gets cancelled, y is less than x plus R. X minus R less than y less than x plus R. So y belongs to R such that y is in between these numbers. So this is just the interval x minus R comma x plus R. Hence the open sphere in the real line, in the real numbers with usual metric is just the open interval. Now the next example is let XD be a discrete metric space. XD be a discrete metric space. XD be a discrete metric space, and this x belongs to x. Then find the following. Open spheres. If your exam held online, then such questions may be asked. The questions maybe are of the form: which of the following is open sphere, or which of the following is metric, or such questions may be asked in your examination. So first we have given that, and one thing must be clear in your mind: given metric is a definition of given metric. If you have given the metric as usual metric, then you can use distance of xy is equals to mod x minus y, and here you have given that the metric is discrete metric, and definition of discrete metric is distance of xy is equals to 1 and 0, 1 whenever x not equals to y, and 0 whenever x is equals to y. That definition of discrete metric, product metric, metric space, all must be clear in your mind. And now we have seen two definitions: open sphere and closed sphere. The definition of open sphere is y belongs to x such that distance of xy less than r. That is, you have to print this diagram in your mind. That is, XD be a metric space, x is center, r is radius, and if you draw this circle or sphere, then all the elements interior to the sphere are the elements of this open sphere. All the elements interior to this sphere forms the set, and that set is called open sphere. And similarly for the closed set, if we include this boundary and interior points of this, then the whole totally forms a closed sphere. So this definition must be clear. Now XD be a discrete metric space, and we have to find the following open sphere. First is S 1 by 2 of x. So here 1 by 2 is radius, center may be any x. Now first of all we will write the given thing. Since XD is discrete metric, XD is discrete metric space, therefore distance of xy is defined as 0 when x is equals to y, and defined as 1 when x not equals to 1. Now SR of x is defined as, the definition of open sphere is y belongs to x such that distance of xy is less than r. Here r is equals to 1 by 2 is given, so we can write that only given things here, and distance of xy is strictly less than 1 by 2. Distance of xy is strictly less than 1 by 2. But XD is discrete metric space, so there are only two values possible, either 0 or 1. 1 whenever x not equals to y, and 0 whenever x is equals to y. But here distance of xy must be less than 1 by 2, and the distance of xy is less than 1 by 2, so 0 is the only possible value for distance of xy, that is distance of xy is less than 1 by 2, and here only two possible values of distance of xy, either 0 or 1, but 1 is clearly greater than 1 by 2, so 1 is not possible, so we have to write this value, distance of xy is equals to 0. The only possibility remains here, distance of xy is equals to 0, since there are only two values, 0 and 1, but which one is less than 1 by 2? 0 is less than 1 by 2, so distance of xy must be 0, and distance of xy must be 0 means y belongs to x, such that x is equals to y. Distance of xy is equal to 0 whenever our x is equals to y, so here x is equals to y, so y belongs to x are all these elements such that y must be equals to x. Y is equals to x means there is only one element. If we take any element of x in this open sphere, distance of xy less than 1 by 2, then there is only one element in that open sphere, which is center, this singleton x, because x is equals to y. If we take any y of that set x, then that y must be equals to y is equals to x, since there is radius is 1 by 2 and only possibility for distance of xy less than 1 by 2 is 0. So distance 0 means x is the only element in this open sphere. Similarly, the second example is yes 3 by 2 of x. Yes 3 by 2 of x. Similarly, here we have xd is discrete metric space. This is sub question, so xd again a discrete metric space. I will just write directly y belongs to x, such that distance of xy less than r means less than 3 by 2. 3 by 2 means 1.5. So there are two possibilities which are either x is equals to y, 0 is less than 3 by 2, again 1 is less than 3 by 2. So there are two possibilities. So, and x is equals to y and x not equals to y, both the possibilities are covered, means this SR of x is total x. All the elements of x are possible. Here x not equals to y and x is equals to y. So there are two possibilities, 0 or 1. So here there are both the possibilities are possible, because 0 distance of xy must be less than 3 by 2. 0 is less than 3 by 2. 0 is less than 3 by 2 and 1 is again less than 3 by 2. Therefore, this whole metric space is covered in this open sphere. So that SR of x is equals to whole metric space x, whole set x. This is open sphere. So these are the examples on open sphere on discrete metric space. Now the next example is, let x is equals to r of real line with standard metric. Then the question is sketch an open sphere. Sketch an open sphere. Yes 1 by 2 of 2. Yes 1 by 2 of 2, that is radius is 1 by 2 and center is 2. Here we have given that, we know that we know the definition of open sphere, that is SR of x is equals to y belongs to x, such that distance of xy is less than r. Here we have to find yes 1 by 2 of 2. So here y belongs to x, x is the real line, such that distance of xy, x is equals to 2 is given, distance of 2 and y is less than r, and r is equals to 1 by 2 is given. But we have given that r with standard metric, that is the definition of metric space is given, that distance of x and y is equals to mod x minus y. So using that definition we can write here this y belongs to r, distance of 2 and y is mod 2 minus y is strictly less than 1 by 2, or we can rearrange this as such that this mod y minus 2 is less than 1 by 2. So using the property of modulus of real line, y belongs to R such that is minus 1 by 2 is less than y minus 2 is less than 1 by 2. Adding 2 throughout, we get 2 minus 1 by 2 is less than y is less than 2 plus 1 by 2. So this y belongs to R such that 2 minus 1 by 2 is 1.5 is equal to 3 by 2 is less than y is less than 2 plus 1 by 2 is 2.5 means 5 by 2. This is the open sphere. Yes, 1 by 2 of center is 2. Yes, 1 by 2 of 2. Y belongs to R. Sorry, y belongs to R such that 3 by 2 less than y less than 1 by 2. So we have to sketch this. So this is the real line. Suppose this is center 0. So this 1, 2, 3, this 4. This is the real line, and we have to sketch this. Now 1, 2, 3, 4. Then 3 by 2 is this point, and 5 by 2 is this. And we know that the open spheres on real line with standard metric are just the open intervals. So this is 3 by 2, this is 5 by 2, this is the center 2. This is the solution. You have to draw this diagram by using pencil and properly. This is the solution.